Welcome to the April community call of ToolJet, and today we have a special guest from Quadrant. So I would like to welcome Jenny on our community call and a quick introduction from your side.
Well, as quick as possible. I always like to talk a lot, but I guess we have the whole hour for that, or however long we're recording. What can I say quickly? I'm developer relations as you, and I'm from Quadrant. This demonstrates it here, truly. And today we're gonna show the power of our both tools combined, ToolJet plus Quadrant. What can it be? Pritesh, please.
Thanks for the introduction, Jenny. And this is the first time we are going to showcase a RAG app on our community call, and we will be building it with ToolJet and Quadrant as our vector database. So, without any further ado, let's jump onto the agenda of the call. So we'll be starting the call with a quick overview on RAG and its evolution, how it evolved, and how it is used and stuff. And then we'll be building the multilingual organization policy RAG chat application in ToolJet, starting with a preview of the application. Then we'll be showing how to configure Quadrant, then chunking and upserting data to Quadrant, and how you'll retrieve and humanize the data to pass in the ToolJet's components at the end. And we'll be then closing the call with some remarks. Sounds good, right, Jenny?
Sounds amazing. And I hope that we will ask each other a lot of questions, and it's going to help us to explain to the people how we can use both of our tools and create this powerful combination. I'm willing to learn a lot today, and I hope you too.
Yeah, likewise. Cool. So let's move to the next part. So over to you, Jenny.
I don't want to overpower community call with me talking for hours about my favorite stuff around vector search, Quadrant, and RAG. So let me just give you a quick overview, which will explain to you why today's community call is so interesting, why it's interesting for you to try RAG and ToolJet, and what actually is RAG, or Retrieval-Augmented Generation. I'm pretty sure you are, if not heard of it, but you have some relation or actually interested into it, because you probably used some AI assistants. We're all users of ChatGPT by now, right? So if you have these AI assistants near to you and you use them to ask all the questions in the world, you would also want to use them every day, including your AI business. For example, it would be nice to have some assistant which helps your clients or answers your questions based on your documentation. It's so cool. You have some assistant which automatically provides you all the answers in the world, and correctly. Well, the correctly part is a little bit tricky. Here, I try to use some open source generational model which are powering this AI, and I asked it a simple question. Tell me in 1-3 sentences about ToolJet. So, Pritesh, what do you think about the answer?
I don't think so. This is a correct definition of what ToolJet is.
Yeah, it doesn't sound exactly correct, right? Well, because these models weren't created to be fact checkers. They were created to be the ones who are generating you in a nice form the information. And that's how it should be used. They forget some information from their vast piles of training data. And also, they don't have the exposition to some private information. And also, they don't know how to update the information, because ToolJet is now this thing, and maybe in 5 years it's going to become the most famous company on earth. And well, these AI assistants won't know that, because they will have to be retrained fully. What they can do actually, and how we can fix this problem of providing false information, is to give them some context about the right data about the world. Look at that. Now I add the context about what ToolJet is, and our model returns a nicely formulated answer, which we would be glad to provide to somebody who is, for example, chatting with the AI assistant about ToolJet. Perfect. So it seems like there is a way to fix this AI assistant and to make it to provide reliable information in a nice format, and then can be used everywhere, from like chatting with your documentation to powering the whole systems of your business with your clients. This way of fixing is actually called Retrieval-Augmented Generation. We are not asking a model to do what it wasn't designed for. to do all the fact checking and to get all the information from around the world. We're providing it with the right context retrieved from a knowledge base, and then combined with this context and the initial question, it provides us a well-generated answer. Here it would be ToolJet is an open source low-code framework. Well, the question is how to get this knowledge base working. What is this knowledge base? And let's talk about that one, how to build it. And finally, in this chapter, you will understand what is Qdrant and why I'm on this call about RAG. So to understand how this knowledge base supports our AI assistant, we need to understand a little bit of basics of vector search. And let's return for a second to our graph. We see that we're getting the question, tell me about ToolJet, and then it gets to the knowledge base and we get the result. So how can we, having this question, tell me about the ToolJet, get some actual facts about ToolJet? Well, we have our way of representing information in vectors. It's done by embedding models, which actually you're going to see further being used in ToolJet for this RAG. And these embedding models convert all the information, not necessarily text, to this vector representation, which has one very specific feature, which allows us to do a search. So all of the information, which is semantically close by meaning, is going to be produced and represented as similar vectors. So we can measure distance between them numerically and use this to find a similar information to what we're searching. And that's how we power our knowledge bases. We come with the questions, which are just somehow formed in a natural language, and then we get all the needed answers similar to them by meaning, exactly what we need. That ToolJet is an open source low-code framework. And how to do it at scale? What are these knowledge bases of vector search? Well, usually for this knowledge base, you have two steps. The first step, you take all of the documents you want to use as a context for the future for AI assistant. For example, it could be some documentation or any other information that you want to store and be sure that it's factually correct. These documents are divided in little pieces called chunks. You're gonna see them later in ToolJet RAG application. Then they are embedded into these vector representations that we were discussing, and they are stored in a vector database. So these documents can be anything. Imagine like your documentation, whatever facts you want to use. And then imagine you want to ask your AI assistant a question to this system, to this knowledge base, which stores all of these chunks of the documents in the vectorized form. Well, simply as that, you just ask your question, which is also can be converted to this vector representation through the same neural encoder. And then this vector finds its most similar counterparts in the vector database. And well, Qdrant is a vector search engine, which is responsible for these two parts, for the storing and retrieving. Or for RAG, it's responsible for the retrieval part. Let's revisit the picture. You have a question to your AI assistant. Might it be about your documents, about your products, or your clients are interested in something about your product? Then, instead of giving it the ability to lie to your clients because it hallucinates and doesn't know the information, you send it to the knowledge base, which is powered by Qdrant. And with this vector search magic, it returns you all the needed answers, semantically close by meaning to what the client or you yourself were asking. And the answer is here, nicely generated by your model with all the right facts. And that's what we are going to build today, isn't it? It's super exciting. I am super excited. Well, and let's talk a little bit more about Qdrant, because as a DevRel, I can't skip this slide. But I mean, I love my company and I love my product, mostly because it's open source, but also because it allows to do this vector search, this retrieval at the very big scale, and at the same time allows to make it very affordable. And here I left you a QR code where you can use our cluster for free for your experimentation. And I think it's very credible because later we're going to build something with ToolJet where Pritesh is going to use our Qdrant cloud, and you could do that simply too. One last thing before we are moving to this exciting part with building, because I am here yapping about some theoretical stuff and showing a lot of slides when it's actually interesting to see something well working in practice. It's one scandalous slide that I wanted to include, which is basically says, I've heard RAG is dead. Well, as AI influencer working in that field, I hear every day that RAG is dead, this is dead, that is dead. Everything is so fast pacing and so much changing every day. So, everybody might look at that and think, well, should I even implement this RAG if maybe tomorrow it's not going to be already at the verge of all of this AI powered business? But no, RAG is not that. RAG is evolving. That's exactly what I wanted to talk about when Pritesh said that I'm going to talk about RAG evolution. We're working a lot in that field, and we saw this evolution with our own eyes. It started with just a vanilla RAG, working with many different types of data and use cases, not only text, also video and images. Then it started being an agentic RAG, which is a whole exciting part separately, where smart models, smart AI assistants use not only knowledge bases, but also other tools like internet or like Slack or something else. And RAG is still needed there. And then the last step of evolution, which is like super popular right now, it's MCP server powered RAG. Like all of these AI assistants that are used now also for coding, for example, Cursor, if you heard about it, they now can use as a tooling Qdrant MCP server, which allows to store not only document information, but also code information. Because when you're coding and your AI assistants helps you to code, well, MCP Qdrant server will allow you to store code chunks of the latest release of your library and allows you to do the code generation correctly, which is super exciting because now you can code only with natural language, still powered by RAG, because RAG is exactly a helper for these AI assistants to do what they were not designed to do, to provide credible information about whatever we want to build our application on. And today we're going to see how it works in practice. So Pritesh, please show us all the magic and let me learn today about ToolJet with all of the listeners of this community call.
Thank you so much, Jenny, for introducing us to the world of RAG. I'm pretty sure a lot of us who might not have heard about RAG before now would be having some context about what it is and how to use it and how to make your businesses better by using RAG and vector databases. And with that being said, we are now going into the building part. So tell me, Jenny, how excited you are.
101%, I think, especially because now we will teach something in ToolJet to answer the questions about ToolJet, right? Well, it's not the use case for you, but like, connecting to my presentation.
So let me start with the preview of the application. So the application that we are going to build is the multilingual policy chatbot, and I'll be showing you the process of how to chunk the policy data, then upsert them to Qdrant, and how to retrieve them from Qdrant to show in the ToolJet's component. So this is the application that we're going to build, that is the multilingual AI chatbot. So on top right, there is a drop down from where you can change your language, and this is the chat component which answers all our queries. So for example, if I can write how many leaves do I get annually, as you can see, it's searching, it created embeddings, and then it retrieved the data from Qdrant, and then it gave the humanized response from OpenAI. So these are the leaves that you get as per the policy of this particular organization, that is the Pexatech. So if I show you the queries, this is how the query looks like. We have JavaScript queries to create chunks, convert chunks into embeddings, and we have Qdrant plugin installed which helps us to observe the data and also query the data from the vector DB. Now let me close the query builder. If you want to get the answer in different language, for example, if I change the language to Spanish and if I ask a question, do we have any health policies in the company? Again, the same process will be repeated, and yeah, you got the answer in Spanish. So this is how the multilingual part works. You can just change the language from top right and you will get the answer according to whatever language you have chosen. And there is one more part of this application, which is the policy knowledge base. So this is where we have stored all the data of policy. So if you see in this particular text area component, we have all the data for the organization policy, and then we have created chunks of this data, and then we have uploaded that data in form of embeddings to the Qdrant database. So I've broken this entire process of building this application into two parts. First is upsertion, like how you upsert the point on Qdrant, and the second part is how you retrieve the data from Qdrant. So let me quickly show you some slides. So in the first part where we are upserting the points to Qdrant, we have seen the data that we had. As I mentioned, we will be chunking that data using the JavaScript queries, and then with JavaScript queries, we'll one by one create embedding for each chunk that we have generated, and then the array of embeddings will be pushed altogether to the Qdrant vector database. So this is the first part. And then if I go to the next part, that is retrieval part. So the retrieval part shows the basic user interaction of this RAG application. So whenever a user asks a question, we create embeddings of that question. Then with that embedding, we search in our vector database where all the data is stored. And from the vector database, we receive the similar data which is relevant to our question, and then we pass the data received and the question to our LLM to humanize the response and get us the final response, which we'll be showing in ToolJet's chat component that I just demoed you. So I have this blank application where I have just a header component that I've created. I have one more page, and here is where we'll be performing the upsert points part. So let me quickly drag and drop the button component, change this to this, and change the label to upload. All right, and then we'll be having a text component, text area component, and we'll be increasing the width to this, stretching it till here. And then we have to add some data in this text area component, and I will be loading the data from one of my JavaScript queries. You can get the data from your DBs as well. So I'll just create a JavaScript query, name it load policy in data, and let me add the data over here. So as you can see, this is a simple JavaScript query where we have, let me just increase the width. Yeah, so where we have the content over here, which is in the markdown format, which has different h1s, h2s and h3s for different set of headings, and then we are just returning this particular string. So if I run this, you can see we are getting the data. And let me load the data in the text area component. I'll just write queries policy load data, and there we go. So you can see the data in the text area component now. Now let me open the queries again. Now the next part is chunking. So we have to create one more JavaScript query and change the name to create chunks. And here also I'll be writing a simple JavaScript function that will create small chunks of the particular data that you can see in the text area component. Let me add the data, and yeah, so this is a simple JavaScript function which is chunk markdown content. So it will be chunking the data based on different headers it has, and then at the bottom, if you see, passing the data from the text area component and then just calling the function and then just returning the chunks. So if you run this, you can see we are getting almost 103 chunks of the data that we have, And if I show you some data, it has ID, then it has text, and it has some metadata for that particular chunk. Okay. So we'll be using all three of them while creating embeddings of the chunks and upserting them to the quadrant. Now next query that we want to create is the OpenAI query. So I'll just write OpenAI, and I have the policy rack OpenAI configuration already configured. So we'll be using this OpenAI query to get the embeddings. So I'll just write get embeddings, change the operation to generate embeddings. There should be embedding 3 large, and here we'll just add 3072 as dimension for this particular embedding. Now next we'll create one more JavaScript query which will convert chunks to embeddings. Okay, so let me add the JavaScript code. If you see the code, initially we are storing all the chunks into this chunks variable. We have this empty array vector data, and then we are just looping chunks, and we are creating a string over here which has the main content, that is the main text, and also it has all the metadata corresponding to that text. Then we are passing that string to the get embeddings query that will get us the embeddings for that particular string. And then if you see, we are creating this object where we are generating a UUID from this function, and then passing the embeddings as vector, and then we are passing a payload which has the main text content and also the metadata corresponding to that content. Okay, and lastly, once the entire for loop is completed, it will be storing all the data of vector data array in the quadrant upsert array, which we can use to upsert to our vector database. Okay, so right now we want to run this query with this particular parameter. So let's go back to the get embeddings over here, and in the input we'll pass a parameter. So we'll pass a parameter called text, and here we can write parameters dot text. Also, every time this embedding is successful, we want to show a small prompt so that we understand that the embedding has been created. You can remove this later, but as of now, just to show the success of the query, I'll be creating an alert. Okay, change this to embedding created. Okay, this will be a success message. Alright, so we are all set for this particular query. So let me run this query. As you can see, the embeddings are getting created for each of the chunk. Since we have 103 chunks, OpenAI query will be running for 103 times, and it will store all the data in our variable. So I think all the chunks have been converted to the embeddings. So if you go to inspector, if you go to page, and if you go to variables, you can see the items over here, and we are having all the data right here. Cool. Now we want to upsert all the data, that is this quadrant upsert array, to our vector database. Make sure you have account in Qdrant and you have configured the Qdrant plugin in ToolJet successfully. I will share the documentation for the Qdrant plugin configuration in the description of this video. So make sure you do that before moving forward. So I am using the Qdrant cloud for this video. You can use the self-hosted version as well. And once you log in and create your cluster and go into your dashboard, you will see this collection window. So we want to create a new collection. So I'll go to the console, and here I'll run this particular query where I'm creating a new collection, and we have the dimension as 3072 because we have used the similar embeddings while creating embeddings for our chunks. So you can run this, and if you go back to collections, you can see we have created Pexa tech policy collection. Now let's go back to ToolJet. And here let's search for Qdrant, and I already have configured my plugin. And in operations we'll select upsert points, and here we'll be passing the data that we have in our variable. So we'll write page dot variables and upsert array. Make sure you stringify the data before you pass. So I'll just write json dot stringify, and yeah, write the collection name as Pexa tag policy. Before I run the query, let me just rename it to Upsert, and now you can run the query. Cool, it shows completed. So if you go back to the collections and refresh the page, you can see you're getting the 104 points over here. And if you open the collection, so Jenny, would you like to help me out with all these options and how someone can use it the best way?
Absolutely. So here is the collection with all the chunks that you were creating of the documents. So the policy chunks, you can see them here. Each of the chunks is a point with all of its textual information and its vectors corresponding to them. You could see them in default vector part. These vectors are of length 3072, as Pritesh was saying. It's because of our choice of embedding model. Of course, we can discuss these choices forever, but here we're using OpenAI, and I guess it's pretty legit to do its job. Here we're also saving different metadata if we want. And besides all of this data, which is obviously vectors and text and metadata, which is not so interesting to see, what's interesting to see is the functionality of this dashboard, which allows to understand the perks of vector search, the ability to compare similar by meaning information, which we can't even explain why it's similar, but it is to us because we understand that it expresses the same meaning. This text is a little bit big for us to understand what it is about, so let me just explain you in general what can you do, how can you play with data here. For example, if you click on Find Similar here, you will get the point, which is the most similar by meaning. So if you would read through the text, it would be exactly the policy which would describe a very similar approach. I don't know, it might be something about sick leaves, or it might be something about like code of conduct. Yeah, so the information is going to be pretty related on that topic. And then you can also explore it visually, because visually I think is the best way to understand vector search. If we open a graph, we could see our points, how they would connect by their similarity in a vector space. And you can explore and see the similar policy chunks and how your data relates between each other, and go deeper and deeper, understanding how this embedding model actually understands the similarity between your data. And this is super cool. There is also another tab which allows us to visualize the data. So if you could go back, and if you go to visualize, you could actually print all of these points. If we will click run, then we will see how our policy chunks are actually grouping together by meaning. For example, if you look at the points close to each other, you will have something which describes the same concept. And I think this is the best way to describe vector search. It allows us to group the similar data in our vector space and use this ability to provide the right contextual information for our assistants. But I don't want to disturb you more, Pritesh. Please continue with your demo.
Thank you so much for explaining these terms to us. These are pretty new to me as well. And it's insane the way Qudrant is showing and helping us visualize our data points. So we are done with upsorting the points. So we'll go back to ToolJet and start the retrieval part where we are retrieving the data from Qudrant. Cool. Let me close the query builder, go to the home page, and here we'll just drag and drop the chat component. Right, chat, and there we go. Now let me just drag the width and height. Cool. Let me change some settings over here. This will be ask me anything about PEXA tech policies. Okay, and I do not want the second part of it, so I'll just remove it. Okay, cool. Then in username I'll just put user, and yeah, cool. So in retrieval part, as I showed you in the last slide, that I explained that we will be converting the embedding of the question, then and querying that from the vector DB, and then we'll be getting the similar data, humanizing the data, and sending the response to our chat component. So let me open the query builder, and let me duplicate this particular query. All right, and I'll just rename this to get chat embedding. Okay, everything remains same, just input will change to components chat last message dot message. Okay, so this is the last message that user will send, and it will be retrieved and used to create embeddings of that particular query or the question. Cool. So on success we are still showing the alert. So just after creating the embedding, we want to search it in the quadrant vector DB. So let me duplicate this and change this to query. Okay, operation would be query points, limit will be 3. Then we do not want vector, so we'll put it false. We want the metadata, so we'll be putting it true, and here we'll be passing the embedding that will be generated from this particular chat. All right, so let's try it out once. So let me type the similar question that we asked in the demo, like how many leaves do I get annually? All right, so this is the last message of the user, so we can get that over here. If you see, we are getting the string, and if you run this, we have created the embeddings for it. Now we'll go to the query, and here we'll just pass that. So we'll write queries dot get chat embeddings dot data and dot embeddings. Okay, cool. And we want to stringify the data here as well, so we'll just write json dot stringify, just pass the data, and then let's just quickly run this. All right, we are getting 3 similar points over here, and if you open the payload, we are getting the data. All right, since the data that we have is very less, we have created a little larger chunk to get more context. Based on the variety of the data, or you can create chunks accordingly. Cool. So now we'll be passing the context which we got from the knowledge base, which is vector DB, to the OpenAI to humanize the response and give us back, which we can pass back to the chat component. All right, so again we'll be duplicating this, and this will be the humanized data. All right, so this humanized data will be the chat operation. Select the model, we'll be using the GPT 4.0, and in message I'll be passing the question that user has asked, and also the data that we got from Qdrant. So let me add the prompt for the message. So let me paste it over here. So if you see, we have passed the last message from the user, that is the question by that is the question asked by the user. Then we are passing the data that we are getting from Qdrant DB, and then we are also passing the chat history just to give more context to LLM so that it gives us the better response to our question. All right. So yeah, now we just want to connect all these queries to run in a particular sequence. So I'll just close the query builder now, and here I'll just add an event handler for the chat component. On message sent, I want to run a query, and this query is get the chat embedding. Okay, so it will get us the chat embedding. So if you go to get chat embedding now, in settings we want to run next query, that is querying the data. So here we'll just run the query, and here I'll just run the query from Qdrant. All right, so now if you go to query, here we want to run the humanized data query. So that will be, if you click on run query, and here humanized data. All right, and if I go to humanized data, here instead of the success, we will just be appending the final response to the chat component so that the response is shown in the UI. And for that, in actions, you can choose control components and then go to chat1, and here just write append history. And now in message, you just pass this particular object with message and type response. As you can see here, we are having queries.humanize data.data, which will get us the data from the LLM OpenAI. All right. The one last thing we want to add for the query is we want to add a small prompt over here, that data retrieved. All right, cool. So now let's clear the history and ask the question again. How many leaves do I get annually? Embeddings are created. Data retrieved, and I got the answer as well. So we're done with building the normal chatbot. Now let's make this chatbot multilingual. So let's add the drop-down component, remove the label. In styles, let's add an icon, search for world, and yeah, cool. Let's make it visible, change the accent color, border color, background, and also change the text color to blue. And last is the icon color. All right, this looks good. Let me just put it over here. Now in drop down, we need to add the language as options. So you can go to properties, change the first property to English, Spanish, and last is, let's say, German. Okay, so these are the three languages. You can add more also if you want to. So by default, let's keep the English as default. All right, now we have to pass this data in our humanized data query as well, so that OpenAI would understand what language they want to give the response in. So I'll just add it over here, that give the response and whatever the drop down value is. Right now, if you scroll down to the bottom, you can see the English is the language. All right, cool. So let's try to change the language to Spanish, and let me ask, do we have any maternity leaves? It will create embedding, then it will retrieve from the DB, get the context to OpenAI, and then give us the response. All right, so it gave us the response in Spanish. So this is how you can build your multilingual policy chatbot. You can build more other type of RAG applications with the support of vector databases in ToolJet.
Okay, so now we have built a RAG in ToolJet with Quadrant. And while you were building, I got myself a couple of questions.
Yep.
For example, if I am a person who is working in ToolJet and I want my RAG being absolutely private, so I am not using like OpenAIs and I am not using Quadrant Cloud, but I'm using our local hosted version. Is it easy to set up?
Yeah, absolutely. So you can connect your self-hosted or cloud, any of your Quadrant setups in ToolJet's Quadrant plugin. So you are not restricted with you want to use cloud or you want to use self-hosted. So you can use anything.
Ah, that's amazing. And what about scaling? Because like I love to talk about scaling since dedicated vector search solutions are, well, exactly tailored for that. So now we saw the small demo example on a couple of chunks, but what if I want to put all of my documentation or even several ones? Is it easy? Is it not a problem?
Yeah, irrespective of how large the data is, ToolJet will be easily able to manage all the processes. Even in case of RAG process, whatever you are doing, creating chunks or everything, it can be done very easily without any second thought.
Okay, that's super cool to know. Then I think we have here a possibility to build a super cool system powered by ToolJet and Quadrant. And it started here with a simple demo, which you can start experimenting with. But of course, RAG is much more than that. You can experiment with embedding models, with chunking, with prompt engineering. So all of these components of the system should be tuned, but when they are tuned, you are going to get a perfect solution to all of your problems. I mean, easily providing them on a daily call, just on a community call. And I will be actually happy to share some links where there will be more in-depth explanation how to make your RAG working. For example, we have a valuation guide and we have a lot of recommendations on how in general to make your RAG work nicely. And I think Pritesh from his side can give you the perfect overview of how to make ToolJet applications the most efficient,
Yeah,
right?
yeah, for sure.
Okay, perfect. Then thank you very much for having me today. And I really, really hope that people are going to try this demo and they're going to come to you and perhaps also to me with a feedback, and we can create even more interesting applications further. So it's not the last time when we are meeting like this.
Yeah, for sure. And I'm pretty sure it was extremely knowledgeable session from you, especially on the RAG part. Most of us are very new to get an understanding about how vectors works and everything. But you definitely made it very simple to understand. And thank you so much for joining the call. And I hope we will be doing furthermore such type of collaborations to share more knowledge to the audience.
Absolutely.